Welcome to the demo of KGROR, a system for interactive data-based reasoning on virtual knowledge graphs. This is work of the Joint Knowledge Graph Labs, which includes researchers from TU Wien, Emmanuel Salinger is the director, the Bank of Italy, in particular from the Applied Research team, see the QR code here, and University of Oxford. I'm Luigi Bellomarini from the Bank of Italy. It's now time to get into the demo. Good. The KGROR system allows to interact and navigate a knowledge graph. A knowledge graph contains an extensional component and an intensional component. The extensional component includes data in the form of a graph. The data come from the enterprise data sources, be they databases, documents, structured and unstructured sources, and so on. There's a typical data management pipeline. You can see the main components, namely data cleaning, schema integration, record linkage, and so on. This is an extremely sophisticated model, and it is part of KGROR, but it is beyond the scope of this demo. Here, we will concentrate on the online part. In a knowledge graph, we have derived knowledge, which we call derived extensional component. It comes from the combination of the extensional component with the business knowledge encoded with a logical language. We use Vadalog, an extension of Datalog. The generation of the derived knowledge is known as reasoning, and the Vadalog system is the software used by KGROR for this goal. Vadalog applies many optimization techniques in the backend. The front end allows the users to interact with the knowledge graph, explore it, and perform their business tasks. The demo will focus on the front end and show a new way to interact with knowledge graphs and to make the most of them in everyday work. The use cases will be based on financial scenarios close to the experience of the authors. You'll understand, though, that these concepts and the idea of exploiting a knowledge graph as we do in KGROR is entirely domain independent. We'll use anonymized yet realistic data. So we're now ready to open the user interface. Let me scroll to it. Good. The main page of KGROR consists of two parts. On the right, we have the rendering canvas, where the knowledge graph will be shown as a graph. On the left, we have the widget. A widget is a wrapper for a Datalog, or better, Vadalog program that encapsulates a relevant piece of business knowledge. A widget is a cohesive, self-contained, loosely coupled logical module which captures a relevant aspect of the domain, and it is used to augment the knowledge graph at runtime while exploring it. Okay, we're almost ready to play the role of an analyst with KGROR. Let's say we want to start a first use case where we wish to investigate the shareholding structure of a company. Before that, let me quickly digress to let you appreciate the typical use cycle of KGROR. So we open the instructions here. The analyst starts by populating the right canvas by selecting and rendering some nodes. This can be done with search widgets. We'll see them. Then she can freely explore the graph by expanding relationships as you would in your favorite graph database. But more interestingly, she can expand the rendered graph by using some reasoning widgets. This process can then proceed in an iterative fashion. Still, as we are working with the data-driven system, we like to know what is the form of the data we'll be dealing with. More technically, what is the schema? We can click here to go to the clickable graph schema section of the application. The tool is schema independent in the sense it can be used with different domains having various schemas. We now click on relationships here, as we're interested in the links involved in the game. We drag it a little bit. Here, we deal with a person entity, either a legal person or a physical person. Physical people or persons can be related to one another. For example, if they are members of the same family. Legal people or persons are companies, in our case, mostly financial intermediaries or banks. Importantly, a person can own stakes, so we say shares, of a legal person, in the sense that it is a shareholder of it. Okay, now that we know the schema, we can go back to the main panel and close this and go to search. Very well. We can retrieve an entity based on any property with full text search. To make things smooth, the tool comes with embedded demo cases that will instruct the search engine to look for some interesting cases, and we suggest the next analysis step. So we said we wanted to see the shareholding structure of a company. We click on ownership and control case here. We see a company, and we can center it. Okay. Now we can use the ownership structure widget to understand something more about its structure. Now we have the chance to look at widgets. They start with a textual description of the domain, and then scrolling down, we finally see the Vadalog code. The widget offers a mapping mechanism to bind input and output predicates to nodes and the edges of the graph. Vadalog code is logic-based, so mapping to a property graph is needed. This is done in the input bindings here and in the output bindings here. The Vadalog snippet in the widget must be launched to apply it to the render extensional component. And we can submit it just after selecting the input. There's a mechanism to perform parameter binding, of course. Now the program is running. Behind the scenes, the UI called Vadalog is sent it the representation of the computation and the data bindings. Vadalog built an optimized execution plan and forwarded it to Spark. We can see what Spark is doing here, and we can monitor it. Consider that computing shareholder is by no means trivial. It involves applying business rules to the overall graph. In terms of magnitude, we are talking about hundreds of millions of nodes and billions of edges, so it clearly takes time. Now we can go back to the main rendering canvas and center the visualization. So far, so good. Now, as an analyst, I may be interested in knowing something more quickly and precisely. We see that a shareholding structure can be quite complex. How can we know who controls my company, this Cinelli, for example? So who takes decision on that? Well, I select the company and I go to the company control widget here. While we talk, we launch the widget just to save some time. Very well. You see again the description here of the domain area. In particular, the widget is telling us when a company A can control another company B, either directly by holding the majority of the shares or indirectly through the control of the majority of the undertakings of other companies. This makes things recursive and complex. Good, let's wait a little bit. It should be almost through. Very well. We can use the force layout here to see a bit better. Well, we see now many yellow edges, which weren't there in the first place. They have been added by our AI assistant, Vadalog. So we can see that Cinelli is controlled by this company controls Meli, and so on. As an analyst, I'm happier than before, but still not entirely satisfied, because through this intricate network of controls, I'd like to see who really ultimately controls my company. Can I do that? Well, you now got the idea. So we click on the company and then on the ultimate controller widget, which is here, and we can launch it. Very well. Now it's processing, and we have the time to quickly look at the Vadalog program and appreciate some important features of reasoning, namely recursion. Finding controllers requires exploring an unknown portion of the graph and doing aggregations. This is an aggregation. Aggregate values must be compared with thresholds to the side on control. Here we are using monotonic aggregations, for which a clear semantics has been provided by Zaniolo and others. Okay, this is the rendering. After the process, we can stretch here a little bit to see finally who ultimately controls this. Bortot ultimately controls Cinelli. Okay, we can now move to another case, and we can clear the rendering canvas for the moment, go back to all and to the search widget here, because we want to evaluate now the influence of a merger and acquisition operations. We want to see how an M&A operation affects the influence of some given company, for example, banks or intermediaries. We go here. We have two companies, and we can center them to see a bit better. And now we want to gradually enrich the rendering canvas for our analysis. And so we click on the enrich mode. Good. Now, first of all, in our analysis, we want to seize the current influence of the companies before being ready to understand the impact of a potential merger or acquisition. So I select the first one, and I go to the influence of control shares, and I submit this widget. What this widget is doing is finding throughout the entire graph all the companies that have shares controlled by the selected one. We launch it, and the idea is that a company A directly or indirectly owns some shares of a company B. When it happens, it's possible that A can exert voting power on B on these shares, depending on the topological algebraic structure of such ownership. Clearly, many definitions exist, and in our battle widget, we are using one. The rendering, as you see, is enriched with the star of influence of our first company. We can center it, we can drag it to try to find, again, the other company. Here it is. And so we launch the same kind of influence analysis also on this company and let it run. We're now computing the influence also for this Coppola company. Actually, the rendering area, we will see that these companies have two big areas of influence. Notice that here, unlike in the initial company control use case, we are exploring the knowledge graph downwards. We are looking at companies whose shares are owned by the main characters, let's say, of our investigation. Let's wait a bit longer, and we are going to see these influence areas in a second. Okay, now we can adjust the rendering again if we manage very well. We can drag out here and can also use the force layout a little bit to have it clearer. And now it's time to simulate the M&A operation. So we click here, we add a relationship. In particular, we add merger and acquisition. Here it is. Very well. And now we need to tell the reason that the two companies are the same. So we select one of them and go to the merger and acquisition inference widget and launch it. While it reasons, we observe that there is an equality generating dependency. That is a rule able to assert that two variables have the same value. Going into details of equality generating dependencies would be too long here, and just out of interest, here we're using the so-called harmless EGDs, for which we have a paper in the research track of ELDB 2023, if you want to read it. Anyway, we now see an entity that connects the potentially merged ones. We can now consider it as a normal company and activate other widgets. We will launch the influence merger and acquisition influence widget. Let me launch it. The goal of this program is the same as the influence one, yet it takes into consideration the MAA and knows where two companies must be considered as a single one while computing the shares. Some of the companies will have controlled shares that were already affected by one of the two target companies, and others will have shares that were actually affected by both the companies. The program is so complex because it combines the effect of the two initial companies in a complex way. For example, if we think again in terms of company control, we have we have that a company can be jointly controlled now, while it was just owned and not controlled before the potential merger. And many other considerations are indeed possible. Here we can drag the company and see that some of them were just affected by one, as I said, and others were already affected by two companies. And so there is some combined effect. Very well. This concludes our walkthrough. It was meant to show a new visual metaphor to interact with the logic-based knowledge graph in a production environment for business-oriented goals. We just scratched the surface of the complexity of the insights that such tools can give. The system already provides much more complex demo cases, which we'll be glad to show and pursue if there's specific interest, also in other domains, of course. So thank you very much for your attention.